everyone. So today I want to talk a little bit about energy calculations. These are kind of interesting because there's not an exact formula for them, but we're just going to kind of like logic our way through it. So now let's talk about another one. In this one, we're using this town Fremont, and it's just kind of like a running joke in AP Environmental Science. This Fremont town, everything in the FRQs always seems to happen in Fremont. The questions are always about this town called Fremont, and it's just this fictional town. And so it's just kind of a running joke that Fremont is like this crazy town environmentally. So in Fremont, water usage spikes during the summer months due to increased lawn irrigation. It's been observed that reducing sprinkler usage by 20 minutes a day can result in a 15% decrease in the water bill. If they reduce their sprinkler usage by 20 minutes a day for the entire month of July and their water bill is usually $120, how much money did they save? Okay, so this is kind of one of those similar problems like where you're doing one of these. And so we're saying that their bill was typically $120 for July. And so we're expecting it to be only 85% of that because that's 100 minus 15 is going to be 85. Okay, so we're looking for what the bill is going to be for July, their new July bill, and then we can figure out what they saved. So we're going to take 100 and we'll have 100x, and then we'll have 120 times 85. And that's going to give us 10200. And we'll have 100x. We'll divide by 100. We'll divide by 100. We can just cross out these zeros. And then we'll get 102. So that's their bill for July. That's not what they saved. That's what they their new July bill is. So then we can take 120 minus 102 and get $18, and that's how much they saved that month. Okay, so maybe they can go to a fast food restaurant for maybe one of them. But if you do that, every month, that's gonna every summer month, that's a decent amount of money, right? So let's get started with this one. So in this one, an individual has been driving a passenger vehicle to work, and they're averaging 60 miles a week in the car that averages 22 miles per gallon. They plan to purchase a hybrid vehicle that averages 50 miles per gallon. If they drive to work 50 weeks a year, how much gas will they save each year if they switch to a hybrid for their commute? So there's a couple things that are the same regardless of which vehicle they have. Okay, there's 60 miles per week is going to be the same regardless of which vehicle they're using, and the 50 weeks a year commute is going to be the same regardless of the vehicle they're using. Okay, so now let's talk about the two vehicles. So we'll talk about the gas vehicle. We'll do some calculations for the gas vehicle, and then we will do some calculations for the other one. Let's pick a different color. We use blue, that'll be nice. And then we'll call a hybrid. Okay, so let's do our gas vehicle first. So our gas vehicle is 22 miles per gallon. Okay, so in this case, we want to see how many gallons a week they're going through. Okay, so we know that they're doing 60 miles per week, and they're getting 22 miles per gallon. Okay, so the way I decided to do this is I was doing 60 divided by 22 because that would be how many gallons a week, but also I was able to figure it out too because miles are going to cross out, and then I'm going to have gallons per week here. So I like doing this dimensional analysis or this method for things like this with units because the units help me make sure that I'm getting the right answer. Okay. Okay, so in this case, he's going to be doing 2.73 gallons a week in the regular car. So now let's talk about the hybrid car. The hybrid car is going to be 50 miles per gallon. Okay, so we're still going to do the 60 miles a week. But instead, we're going to do 50 miles per gallon. Okay, and that'll give us our gallons per week. And that's going to be 1.2 gallons a week. Okay, so now we need to figure out how much he's going to save each year. Okay, so there's a couple ways you can do it. You can multiply each of these by 50 weeks a year and then take the difference. But I actually prefer, I think it's a little quicker to just do your 2.73 minus 1.2. And that's going to give me 1.53 gallons a week. And then I can multiply that by 50. And just to show you that the units work out, I'll show you we have gallons per week. And then we have 50 weeks a year. So this is going to give us gallons per year. And so that's 76.5 gallons a year. And that's going to be how many gallons they save per year. And then if you know how much the gas costs, you know, like $3 a gallon, $4 a gallon, whatever it is, then you would know how much money they would save per year. So hopefully this helps you answer this type of a question. So now let's go to the next one. In this one, this family is comparing two different televisions, and they're trying to see if it's worth buying the second television. Okay, so television model A consumes 100 watts per hour when in use, and on average it's used 6 hours a day. It typically lasts 10 years before needing replacement, and it costs $500. And then each kilowatt of electricity costs 15 cents. So we're getting a lot of numbers here. We'll move them to where we want them once we finish underlining everything. Okay, and then a homeowner is considering purchasing a new model, Model B, which uses 30% less energy per year. And so we want to know the yearly energy savings from between television A and B. Okay, so the things that are the same, regardless of which TV we use, is how much they watch TV, which is 6 hours a day, and the cost of electricity. Okay, and then we're going to compare TV A and TV B. So we have TV A, and then over here we'll have TV B. Okay, so the first thing I want to do is we want to find out, we want to switch all of this to kilowatts because we're in, our money is going to be in kilowatts, and so we need to adjust this. Okay, so our TVA is 100 watts per hour. Okay, the hour is totally okay because it's kilowatt hours, so we're fine with that. So, but we need to adjust the watts. So there are 1,000 watts in 1 kilowatt. Okay, so that's going to mean the TV uses 0.1 kilowatt hour. Okay, or kilowatts per hour, excuse me. Okay, and then we can take that and we can see how much it cost for the year for this TV. So we will take our 0.1 kilowatt hour and, it's kilowatt per hour. I keep writing this wrong and it's confusing me. So let me write this correctly so I don't confuse you or me. So kilowatts per hour. And then we know that we're using it 6 hours a day. Okay. And so that's going to give us 0.6 kilowatts per day. And if we're using it on a regular year, which is, we're not talking about a leap year or anything crazy like that, we'll have kilowatts per day. And then 1 year has 365 days. Okay, and it helps because if you write it like this, then you know where to cross out your units. So it just kind of helps me keep things straight. Like if I get confused or if I like put it upside down, then I'd be like, oh, my days aren't going to cross off. I must have did that wrong. So it's just a way to kind of like keep yourself straight. So 219 kilowatts per year times 15 cents is going to give us 32.85. So it's going to cost us almost $33 a year to use TVA. Okay. So now let's talk about TVB. Okay, it's going to use 30% less energy. So it's going to use 70% of the energy that it used before. So we're going to take this 219 kilowatts per year, and I'm going to put it here. And since it's using 70 of, we want to look at, it's going to use 70% of that. Okay, so I'm going to do 100x equals 70 times 219, and I'm going to get 153.30. I'm going to divide by 100, and so then it'll be 1533 divided by 10, which is 153.3 equals x. So that's how much kilowatts per year we're going to use with TVB is 153.3. So now we need to multiply that by our 0.15, and we will get, it's like 22.995, and since numbers money doesn't really go that far out, I'm going to say it's 23. Okay, so then we're going to take our 32.85 and we're going to minus $23 from it, and we will save $9.85 a year. So we're not saving that much per year. Depending on how much this new TV costs, will we make up, the cost in 10 years, if it lasts for 10 years. It just depends. So if your TVA is not totally destroyed yet, it's still working, it might be something where, $10 a year is not really worth it for you to buy a new TV because you have to pay that upfront investment. But it's, it's totally up to the homeowner. They have to decide that if it's worth it. But if they're thinking about getting a TV anyway and they want to justify it by saying they're going to save $9.85 a year, then, good for them. So let's try another one. This is kind of a weird one. We're going to talk about a school district. So again, we're talking about Fremont, and we say the Fremont School District consumes 8.5 times 10 to the 12 BTUs of energy per year for lighting and heating the school buildings. And then they're telling us the cost of 106 BTUs is $15, which is kind of weird number, but we'll go with it. And then if the district enforces regulations requiring all school buildings to be 30% more efficient, how much will they save in 1 year? Okay, so let's think about this. So first we have this 106 BTUs. And equals $15. So let's put that in something a little more reasonable. So let's say we have $15 for every 106 BTUs. That's going to give us 14 cents per BTU, which makes a lot more sense. Okay, so I'm going to put a box around this so I have this. And then we know that they're using 8.5 times 10 to the 12 BTUs, and they need to be 30% more efficient. So that means they're going to use 70% of that energy. So we've got this huge number, but it's not going to scare us. Times 10 to the 12. And it's the same kind of thing. We want to know what 70% of that is, because that'll be what the school district uses next time. So we will have 8.5 times 10 to the 12 times 70 equals 100x. Okay, now this is where it gets important. So let's look at our calculator. When we're putting stuff like this in the calculator, we need to make sure that we're putting it in correctly. Okay, so I like to go ahead, anytime I'm using an exponent, I like to go ahead and put it in parentheses. Times 10 to the 12. Okay, that's going to give us the correct number. Now I want to multiply that by 70. Okay, and that's going to give me 5.95 times 10 to the 14. So I'm going to put that in there. And do you see how I checked it at first to make sure? Because sometimes this little e right here, they use that for the exponent, and sometimes they use it for like e, like the irrational number e. Okay, so what was our number again? We had 5.95 times 10 to the 14. Okay, so we'll do 5.95 times 10 to the 14 equals 100x. And we're going to divide that by 100. We're going to divide that by 100. And then we'll have x equals, I'm going to go back here to my calculator. I'm going to divide by 100. And it's going to give me 5.95 times 10 to the 12. Okay? Okay, so now we need to see, excuse me, how much money this costs. Okay, so what I'm going to do is I'm going to say my original money, and I'm actually going to put that in a different color so we can keep it. Well, all of yeah, I'll put the original cost. And we'll do 8.5 times 10 to the 12th times 0.14. Again, I'm going to put this in my calculator. I'll do the parentheses, and I'm going to do the 8.5 times 10, and I'm going to use this little up guy to the 12th. And that'll give me my number, and then I'm going to multiply that by 14, which is 1.19 times 10 to the 12th. So that's what the original cost was. Okay, now let's figure out what our new cost is, and then we can figure out the savings. Okay, so we're going to take this 5.95 times 10 to the 12th that we found earlier, and we're going to multiply that by 0.14. And I'm going to do 5.95 times 10 to the 12th. Okay, so 8.33 times 10 to the 11th times 10 to the 11th. Okay, and now we're going to take these two numbers and we're going to take the difference between these two numbers. So we need to take, this one was the original number, and so I'm going to do this over here. I'm going to do this 1.19 times 10 to the 12th. I'm going to minus 8.33 times 10 to the 11th from it, and whatever answer I get, that's going to be how much we save. Okay, and it's going to be a weird looking number. I'm going to tell you that right now because I already practice solving these for you, and I did it like 3 times because I thought the number felt a little weird. Okay, so we're going to have, that's our first one, and then we can do minus, and then we can do the other one. Notice I'm still doing parentheses. Okay, whenever I'm dealing with exponents, I want to put parentheses because I just never know if my calculator is going to think that like it's 8.33 times 10 to the 11th, like a number, like 2 different numbers, and I don't want it to screw up. And then this is our number, 3.57 times 10 to the 11th. Which is money that I don't have any experience with money numbers this large, which is probably why it doesn't look, it doesn't make sense to me. But that's how much they're going to save per year. So that's a lot of money, believe it or not, because the school district is using so much energy per year. The same type of question where we're going to be comparing some things, and then we're going to see which one is how much money we save. Okay. But this one I do feel like I thought was a little more difficult. So natural gas is often priced in units of dollars per therm. 1 therm equals 100,000 BTUs. A certain family uses 600 therms of energy to heat their home annually using a furnace that's 80% efficient. The family is considering replacing its current furnace with one that is 96% efficient, and assuming the cost per therm is 30 cents, what is their annual savings? Okay, so again, the things that are the same regardless of which heater they use is 1 therm equals 100,000 BTU, and that 1 therm equals 30 cents. Okay, and then we'll look at our two. So we'll look at our one that's 80% efficient. And we'll look at our one that is 96% efficient. And then we'll compare them. Okay, so, excuse me, the current heater is, they're saying that they use 600 therms, given that it's 80% efficient. So I'm going to do one of these. Maybe you remember these from, what is it, elementary school, middle school. Okay, so at 80%, we know that's 600, and so we want the X. And first I did it this way, and I thought that was a little confusing to me, so I actually switched it to doing 20. So I took the 80 minus the 20 and did it this way. And I thought that was a little better because that was going to give me the extra amount. And so, okay, so here we go. We're going to take 600 times 100 equals 20x. And this is going to be 60,000 equals 20x. And, you know, you can put whatever you want for x. If it's confusing that you have x and x, that's totally fine. And so then I got 3,000 okay, and then I'm going to go the other way. Okay, so I'm going to go over here, and I'm going to do, this one is, we don't know how efficient it is. I mean, we don't know how much they would use with this, but we know that their total use was 3,000, and 100 minus 96 is 4, so I'm going to put the 4 here. So I'm going to have 100x equals 3,000 times 4. So I'm going to have 100x equals 12,000. I'm going to divide by 100. And I'm going to get x equals 120 therm. So instead of using 600 therm, they're going to use 120 therm. So now we want to know how much they save per year. And so we can take this, this 600 and we can multiply it by the number, the money, and then the X, this one by the money. Or we can do exactly what we did in the other problem, is we can take 600 minus 120, which gives us, so I'm going to do 600 minus 120, and that's going to give me 480. Okay, so then I'm going to have 480, and then I can take my 480 and multiply by 30 cents, and that's going to be 144. So they'll save $144 a year. So then we can discuss the cost. The family could decide, depending on how much the new heater costs, if it's worth that $144 of savings a year. For example, if the heater lasted 10 years and it cost $1,000, they would make, that they would cost $100 a year, so they'd save $44 a year, which over $10 years would be like $440 or something like that. So the family will have to decide if the upfront cost is worth the annual savings for the heater. And everybody has to do that, all families, when they're deciding what type of, if they want to upgrade to something more energy efficient.